AOPS counting and probability 2.30. In how many ways can you spell the word noon in the grid below? You can start on any letter, then on each step you can move one letter in any direction, up, down, left, right, or diagonal. You cannot visit the same letter twice. So if you start at one of the four ends in the corner, there's one choice for the first O because it's the diagonal O. There's three choices for the second O because it's the three O's around that O, the first O. And there's five choices for the second end because there's one beside, there's one diagonal over here, and also there. So in total, there's 4 times 1 times 5, 4 times 1 times 3 times 5, which is 60 ways to start at one of the four ends in the corner. Or you can start at one of the 8 ends at the sides. So there's 2 on each side, so there's 8. So there's 2 choices for the first O because it's the one in front or diagonal. There's 3 choices for the second O because it's the 3 around it. There's 4 choices for the second N if the second O is not adjacent to the first N. So if we start at this and then we go to this is adjacent. So there's 4 choices for the second. There's 4 choices for the second N. And if you choose like the diagonal one, if you have this N and then this O, it's diagonal. So there's 5 choices for the second N if it's the other 2 positions. So in total, there's 8 times 2 times 2 times 5 plus 1 times 4 because 4 and 5, which is equal to 224 ways if you start at one of the 8 ends at the side. So 60 plus 224 is 284 ways in total. AOPS counting and probability 2.32. Let S be a cube. Compute the number of planes which pass through at least 3 vertices of S. So case 1 is when the plane contains a face, like in this diagram. So these 4 points, you can connect them to make a plane, and it's a face of the cube. So there are 6 faces, which means there are 6 planes in this scenario. Case 2 is when the plane contains parallel edges. So it's like this in this diagram. So there's 2 parallel edges. And since there are 12 edges in total, that means there are 6 pairs of edges. So there are 6 planes. And case 3 is when the plane does not contain an edge. So it's like this one. So there's 3 vertices that are connected inside, but they don't have any edges or faces. So like if it's a plane, it's basically like this inside the cube. So there are 8 planes this way. There are 8 combinations of points that are like similar to this. So there are 8. So in total, there's 6 plus 6 plus 8, which is 20 planes in total. AOPS counting and probability 2.34. How many 5-letter words, where any string of letters is a word, have at least 2 consecutive letters which are the same? So the total number of 5-letter words is 26 to the power of 5. And it's easier to calculate the 5-letter words with no 2 consecutive letters, so that's 26 times 25 to the power of 4, because if you have 26 choices for the first one, and then you have 25 to the power 25 choices for the next few, because you can't have the same letter as the first one, so it's 25. So 26 to the power of 5 minus 26 times 25 to the power of 4 is the number of 5-letter words with 2 consecutive letters the same, which is 1,725,126.